Welcome to GMST. I'm Anil Kumar DRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 9. So that is a speed control of a separately excited DC motor using IGBT or MOSFET chopper. So aim to turn on the single phase full wave rectifier using single phase converter using firing circuits. Aim of the experiment theory. Apart is required circuit diagram, procedure, calculation, results and graph. These are the contents. Here the speed of a separately DC motor is controlled by the varying the armature voltage using a DC chopper employing a semiconductor switch such as IGBT or MOSFET. The field winding of the motor is supplied from a separate DC source, so the field flux remains constant. The chopper operates rapidly with switching the IGBT or MOSFET on and off at a high frequency, and the average armature voltage is controlled by changing the duty cycle of the switching signals. When the duty cycle increases, the armature voltage increases, resulting in the higher the motor speed, the duty cycle decreases. Voltage and motor speed can be controlled easily. So aim is to control the speed of a separately excited DC motor using IGBT or a MOSFET chopper. This is actual circuit diagrams. So we have the IGBT, that is gate collector and emitter terminals. We have the motor here. So that is DC motor. It is connected to the motor field windings, and we have the 220 volt DC supply, and we have the selector switch also. We have to select for the two. And apparatus required DC motor control, DC motor control unit, DC motor voltage selector and the field supply. So procedure connections are made as per the given circuit diagram. Keep the voltage selector switch on off positive and the switch on the main supply to the circuit and to the field winding. Now keep the voltage selector switch at the position 2 and measure the voltage at VOC terminals. Vary the duty cycle and observe the load voltage and speed. Tabulate the readings of the speed and the duty cycle by increasing the speed. Plot the graph duty cycle versus the speed. So this is actually the readings we have got during the conduction of the experiment. For the 20% of duty cycle, we have calculated the T1 as a 4 divisions into 5 seconds. That is the volt per divisions. We have to multiply what is the divisions, that is a 4, and 5 second is the time per divisions in the CRO. So it is 4 into 5, 4 into 5, that is millisecond will give us a 0.02 time T on. Similarly for the T off, 17 into 5 millisecond will give the 0.05 T off. Speed during that time speed is 181.1, and T is T1 plus T off, that is 0.105, and K value is T on by T is 0.19. Similarly, we should find out for the 40%, 60, 80 and 90% also. So this is actually graph you have to plot. That is a duty cycle in the x-axis in terms of percentage, and speed in the y-axis, that is in the RPM. So result, the speed of the separately excited DC motor using IGBT or MOSFET chopper is analyzed. So let us see how the experiment can be conducted in the real time. Let us go with the conduction for the experiment now.
Hi, hello everyone. I am Anil Kumar DRB, Assistant Professor, Department of Electrical and Electronics Engineering, GMST Davangere. So today we are going to study the speed control of a DC shunt motor, separately excited DC shunt motor using IGBT and MOSFET on chopper circuit. So apparatus required is DC motor speed control unit, that is IGBT or MOSFET using chopper. Then we require the DC shunt motor. This is the DC shunt motor. I am the 0.5 HP motor. Then we require the CRO, that is cathode ray oscilloscope. So now we have to make the connection as per the given circuit diagrams. The driver output. So that is the driver output of the gate is connected to the gate of the IGBT. Then driver output is connected to the CRO. Then we need to select the selector switch, that is 2. Then we have to see whether we are connected for the field winding. That is the field shunt field windings to the field of 220 voltage DC supply. Then we select the selector switch to the 2. So after making the connections, we need to check in the control circuit the IGBT or MOSFET which we have selected. That is, we have selected for the IGBT, so it is showing the IGBT chopper. So in this IGBT chopper, we have to select the duty cycle by incrementing or decrementing. So once it is incrementing or decrementing, you have to select the 20%. Frequency is 50 Hz. So after selecting this, we have to go for the run. So once we run, the motor will start running. The motor will start running. We need to see what is the waveforms in the CRO. So this is actually the waveforms. This is the on time and this is the off time. So upper side you can see this is the on time and this is the off time. So on time divisions we have to calculate. That is 0.8, 0.8, 0.2, 0.4, 0.6 and 0.8 into 5 milliseconds. We have set it for the 5 milliseconds. So 0.8 into 5 milliseconds. That will give the T on time. Similarly, you have to calculate the T off time. That is around 3.2. So 1, 2, 3, 3.2. 3.2 into 5 milliseconds. So that will be the T off times. Similarly, we need to check what is the speed in the DC motor. The speed is around, it is going to be around So it is 180 something, 263. Alright, so we need to record the readings. So this is taken for the 20%. The T on time is 0.85 millisecond, T off time is 3.2 into 5 millisecond. Speed is around 328, T is 4 and K value is 0.25. That is T on by T off time, that is 0.25. Simply you have to calculate for 40%, 60% and 80%. Okay, thank you.